We'll show you how to find the coordinates of the center, foci, and vertices, as well as the equations of the asymptotes for a hyperbola given in a standard form. Let's consider the equation x minus 3 squared over 4 minus y plus 2 squared over 16 is equal 1. We'll start with looking for the center. We have to remember that this hyperbola is obtained by shifting the hyperbola with center at 0, 0. So by considering this, we can figure out the center, because if you look at the equation, we have the term x minus 3 that indicates that the shift is to the right by 3. And then we have y plus 2, so that indicates that the shift also is down by 2. And therefore, the center is at the point 3 and negative 2. Also, if you are looking at this equation, you can notice that the minus sign is in front of the term with y, which means that the vertices and foci are on the line that is parallel to the x-axis. And this also tells us that the value in the denominator underneath x term is a value of a squared, and the number in the denominator of the y term is b squared. So b squared is 16. Once we have a squared and b squared, we can find the value of c. B squared is c squared minus a squared. Therefore, c squared is a squared plus b squared. This is sum of the numbers in the denominator in this equation. 4 plus 16, which is 20. So that gives us the value of a to be square root of 4 or 2, value of b to be square root of 16 or 4, and the value of c to be square root of 20, which is 2 square roots of 5. Once we know value of a, we know the distance between a center, between the center and a vertex. So we can plot those points, vertices, in the coordinate system. We know that the vertices are on the line parallel to the x-axis. So starting with the center, we'll move a units to the right to get the vertex v sub 1, and we'll go 2 units to the left to get the other vertex v sub 2. So we can write the coordinates of the vertices by using the graph. Vertices are at the points 5 and negative 2 and 1 and negative 2. Now, to find the coordinates of the foci, we use the fact that the c is the distance between the center and a focus. So as with the vertices, we'll move in that direction, horizontal direction from the center. We'll move square root of 20 units to the right. This will be c equals square root of 20, and to get the focus f sub 1, and we go by the same amount in the other direction to get the focus f sub 2. So the coordinates of the foci, therefore, are going to be, well, focus f sub 1 was obtained by, you can say, shift of the center c by square root of 20 units to the right, and therefore its x-coordinate, the coordinate of the center, which was 3, was increased by the amount of shift, which is 2 square roots of 5, and the y-coordinate stayed unchanged. For the focus f sub 2, we decrease the coordinate by 2 square roots of 5, and the y-coordinate stay unchanged. So these are foci. So now what we need is the asymptotes. To find the equations of the asymptotes, we'll use the geometry again. We'll draw the asymptote box using the value of b. So using the value of b, we'll start with the center and we go perpendicularly to the axis, transverse axis. This is b equal 4. We'll obtain the point that will determine the rectangle, and we'll go b units down to obtain another point. And now we are ready to draw a rectangle. That rectangle is going to go through the vertices and the points that we just plotted. And the asymptotes are going to be diagonals of that, or will be included in the including diagonals of that rectangle. So we know that the asymptotes are passing through the center. So we have at least one point on the asymptotes. We have the point 3 and negative 2. To write the equation of asymptotes, we need the slopes. So if you look at the line that goes through the center and this vertex of the rectangle, this line has the slope m equals, well, we'll start with the center, and to get to that point, that vertex of the rectangle, we'll have to run 4 units, run b units, and then, we have to rise b equal 4 units and then run 2 units. So the slope is 4 over 2, which is 2. The slope of the other line is going to be just opposite of the slope that we just obtained, and you can also use the geometry here to find that slope. So we have two asymptotes. One has the slope 2 and the other one has the slope negative 2. If you use the point and the first slope, you will get the equation y minus y coordinate of the point, so it's y plus 2 is equal slope times x minus x coordinate of the point. And if you use the point and the second slope, we'll get the equation y plus 2 is equal negative 2 times x minus 3. And if we write these equations in the slope-intercept form, the first equation is going to be 2x minus 8, and the second equation will be y equals negative 2x plus 4. And these are the asymptotes of that hyperbola. An alternative way of doing this problem is to memorize all relevant formulas and apply them to this case.